Properties of Logarithms. There are three properties of logarithms that we need to know. The first says that if you have the log of the product of two things, that this is equal to the sum of the logs of each of the individual factors. Notice that for this to be true, whatever the base is here, you have to have the same base here and here. The next property says if you have the log of the quotient of two things, this is the same as the log of the numerator minus the log of the denominator. And finally, if you have the logarithm of something raised to a power, the power can be brought down and multiplied to the logarithm. These properties can be used to either expand or simplify expressions. So for example, in this problem here, it says expand using the properties of logarithms. So right now we have a single logarithm, base 5, of 3xy over z. So what we want to do here is expand it, meaning that we want to write this as a sum or difference of multiple logarithms. Well, the second property on the previous page says that when you have a single logarithm of a fraction like this, you can take the log of the top, so that's going to be log base 5 of 3xy, and then minus the log of the bottom, which is log base 5 of z. Now from here, is there anything else we can do? Well, in the second part of this is finished. There's really nothing that could be done here. But in the first part, we have the log of the product of three things. We have the log base 5 of 3 times x times y. And the log of this product can be broken down into the sum of three individual logarithms. So this is log base 5 of 3 plus log base 5 of x plus log base 5 of y, and finally minus log base 5 of z. And so what we've done is we've taken this very simple, compact expression and we've written it as an expansion involving multiple single logarithms or logarithms of single expressions. Our next example is basically the same thing. We'd like to expand this using properties of logarithms. So once again, we have log, this time base 2, of a fraction. Okay, so just like in the previous example, we have a fraction once again. So we're going to start by taking the log base 2 of the top of the fraction minus log base 2 of the bottom of the fraction. Okay, now, in this first expression, it looks like maybe we're done, but there is one thing we can do. This 4 right here can be brought down in front of the logarithm. So this becomes 4 times the log base 2 of x minus, and now this one can be expanded just like we did in the previous example. So we do have the square root of y multiplied by z cubed. So this is going to become the sum of the logs of each of these things. So we have log base 2 of the square root of y plus log base 2 of z cubed. Now you got to remember, we were subtracting this logarithm, and this logarithm is the sum of these two individual logarithms. So we must put parentheses around this because this negative applies to both of these. So in our next step, we'll go ahead and distribute the negative. So this becomes 4 log base 2 of x minus log base 2 of square root of y. Let's rewrite that as y to the 1/2 power. And then we have, whoops, that should be a minus there, right? Minus log base 2 of z cubed. So I'm distributing this negative to each of these, and I'm also changing the square root to a 1/2 power. And our final step is going to be to take these powers and bring them down in front of each of these logarithms. So we end up getting 4 log base 2 of x minus 1/2 log base 2 of y minus 3 log base 2 of z. Now in this next example, we're basically just doing the opposite. So here we have an expansion of logarithms. Notice that they are all base 10. And we want to bring them together to write it as a single logarithm. So here we have 2 times log base 10 of a plus 3 times log base 10 of b minus 1/3 log base 10 of c. Now, before we can combine these together, the first thing we need to do is any number in front needs to be brought up as a power. So this is just the opposite of what we did in the previous example. So this first one becomes log base 10 of a to the second power. And then we have plus log base 10 of b to the third power. And then minus log base 10 of c to the 1/3 power. Now to do the rest of this, I can take this one step at a time. These two logarithms, if I add them together, we get a single logarithm, base 10, and we are simply going to multiply these together. So we get a squared b cubed, and then minus log base 10 of c to the 1/3. And now we can combine these into a single logarithm. And when you're subtracting, it turns into division. So a squared b cubed goes on top, c to the 1/3 in the bottom. And you could leave this as your answer, or you could change c to the 1/3 to be the cube root of c. And finally, properties of logarithms can also be used to help you solve equations involving logarithms. So in this equation, we have log base 2 of x plus 2 plus log base 2 of x is equal to 3. So what we can do here is we can combine these two logarithms together. This becomes log base 2 of x plus 2 multiplied by x. So I'm going to write x times x plus 2 equals 3. Now from here, to solve this equation, we're going to get rid of the logarithm by writing this in exponential form. So we're going to say 2 raised to the 3rd power is equal to x times x plus 2. So x times x plus 2 is equal to 2 to the 3rd power. And this means x squared plus 2x is equal to 8. Now to solve this equation, of course, this is just a quadratic equation, so we can subtract 8, set it equal to 0, and this one factors kind of easily. And this is going to give us two solutions, x equals negative 4 or positive 2. Now, if you plug in x equals negative 4, you end up getting log base 2 of negative 4 plus 2 plus log base 2 of negative 2 equals 3. And this is not true, okay, because you have the log of a negative number in both of these spots, and we can't take the log of a negative number. So negative 4 is not an answer. Now, if you test the other solution, positive 2, we get log base 2 of 2 plus 2 plus log base 2 of 2 is equal to 3. And notice that this is log base 2 of 4 plus log base 2 of 2 is equal to 3. So we no longer have negative numbers inside of our logarithm, so we should be good to go here. So the only answer to this problem is x equals 2. And one additional example here, suppose I want to solve for x in the following equation. So just like the last problem, except that now when I combine these two logarithms together, notice we have a minus sign. So this is going to turn into log base 2 of x plus 3 over x minus 3 is equal to 2. And then we can convert this into exponential form. So that gives us x plus 3 over x minus 3 is equal to 2 to the 2nd power. And that is x plus 3 over x minus 3 is equal to 4. And then we'll just multiply both sides by x minus 3. This will allow us to cancel these out. and we get x plus 3 equals 4x minus 12. Finally, subtracting x from both sides and adding 12 to both sides, we end up with 15 equals 3x, which of course means x equals 5, and if you check that answer, it works. And that concludes this video lesson.